Basically, what you have to know is about the relationship of mole fraction. Okay, if you have binary mixture, okay, you have component A and component B, okay, the mole fraction should give you the total or the sum of the mole fraction will give you the value of 1. Okay, right? So in the liquid form, okay, are you going to use X? In the gas form, we are going to use Y. Okay, and then at the same time also, you should know how we get the total pressure. It's come from the partial pressure of vapor, partial pressure of A in vapor phase, plus the partial pressure of vapor in for component B. Okay, so that is how you get the total pressure. Okay, and then using the Rod's law, okay, how do you get the partial pressure of A in vapor phase? You get it from the mole fraction of liquid. Okay, mole fraction of liquid multiply with the vapor pressure of that particular component. Okay, so this is how you use the Rod's law. Okay, and then get used to the information that you have learned before, which is called the boiling point diagram. Okay, so you're gonna have boiling point diagram. Okay, so this is the introduction. Okay, so meaning that you should know how the boiling point diagram is developed. Okay, and you can see here, okay, you have area here. Okay, you have 3 areas. One is called liquid region. Okay, another one is called vapor region. But in between, you have mixture of liquid and vapor. Okay, so you have to introduce external heat energy to the system. Okay, to run the distillation process. Okay, but for liquid extraction, we are not going to use. We are not going to apply the heat energy or external heat energy. Same thing with the gas absorption. So what you can see here, all right, when we talk about distillation, we're going to play a lot with the boiling point diagram. Okay, and there are situations in the distillation process. There are situations in distillation process where the condition, okay, the condition of the feed, all right, condition of the feed. Okay, when I say condition of the feed, this is a very important information in distillation. Why? Because you can only control the condition of the feed. You can only control the condition of the feed. So once it is in the column, it is out of your control. Okay, except the operating condition, the temperature, the pressure in the column. So after that, you're going to get the product. Okay, so why do you need to control your feed? Because you need to achieve, you need to achieve quality of the product that comes out from your distillation process. Okay, so that's why for you to know to get the quality of the product that you would like to have in your end product, you should control at early stage, which is come from the feed. Okay, come from the feed. So that condition come from your feed is called the feed condition. Okay, so what is the feed condition? The feed condition actually involve the temperature of the feed. Okay, the phases of the feed, whether it is in liquid form, whether it is in vapor form, whether it is a mixture of liquid or vapor. Okay, so this will represent the condition that you would like to use in order to get your final result that you want. Okay, so the term used can be here saturated liquid. Okay, the term used in this particular chapter. can be saturated liquid. The condition of the feed is in saturated liquid form. Okay, maybe in saturated vapor form, maybe in liquid form, maybe in the vapor form, maybe as a mixture of liquid and vapor. Okay, so there are a few things here. Sometimes they use the feed is at boiling point, macam tu. Okay, so if the feed is at boiling point, then you should know, okay, where is that situation? Is it saturated vapor or is it at saturated liquid? Okay, all right, try to figure out that. If I say that the feed is at boiling point, okay, what does it represent? Is it saturated vapor or is it at saturated liquid? Okay, so think about it. All right. Okay, any question before I proceed to the second part? Okay, so if you have questions, just voice out. Okay. All right, next, before I go to the next slide, so in boiling point diagram, you should have temperature versus mole fraction diagram. Okay, all right. So in the boiling point diagram, you can have a representative of mole fraction of the liquid or mole fraction of the vapor. Okay, but when you say that the condition of the liquid and the vapor when they reach equilibrium, okay, they should have temperature at that particular certain the same temperature exists when you have the component for X and the component for Y. So at this same temperature, the composition of vapor, okay, the composition of vapor and the composition of the liquid, they are in equilibrium. Okay, all right. So for the ease of our understanding, okay, when we get to solve the problem, we always assume that the composition or liquid composition and the vapor composition at one particular trace or at one particular stages, they are always in equilibrium. Rod's law and Dalton's law, okay, will be used in this VLE composition. So we are dealing only with binary mixture, okay.